This is my brain. 192 MRI slices or images strung together to produce a spectacular image from ear to ear. Getting a brain MRI means keeping still for a good 45 minutes and wearing some pretty uncomfortable headgear.
So we're going to start up with the first scan. From here on out, you got to keep as still as possible.
This is an fMRI, a functional MRI that will actually pinpoint changes in blood flow inside my brain.
What we can do with that is determine which areas of the brain are active while a patient may be thinking of something or maybe talking.
And happily enough, the changes that occur in blood flow happen at such a small scale that you can actually localize areas of the brain that are active in the performance of various tasks.
All right, here we go.
We'd like you to imagine you're on a tennis court with a tennis racket in your hand.
The object of this test is to see how well I can imagine an activity without actually doing it. So, I swing a forehand, serve up an ace, launch a lob shot, and so on. Researchers hope that this type of study will help them determine whether patients in vegetative states or comas can understand and follow commands even if they can't communicate.
So this is a task when we ask them to imagine they're playing tennis, and we know that the areas that activate in the brain when you're doing this task are similar than the areas that activate when you're actually playing tennis or moving your arm. And we're trying to see where these areas activate in the patient, and that way knowing whether the patient is capable of following our instructions.
Remember, I'm staying perfectly still. I'm not even holding a racket. But the supplementary motor area, the part of my brain that controls movement, is lighting up like a Christmas tree.
You can see that at the beginning when he's not imagining the task, we get a baseline of activity. And as soon as he starts imagining playing tennis, the brain activity in the SMA will increase. And then once he stops, during the rest period again, it drops back down again. And so you can see over the course of time, you can see how his brain was thinking about playing tennis.
It was pretty amazing to see my vocal cords vibrating, pictures taken by a tiny camera that I'd swallowed. But if you think that was kind of amazing, check this out. My obsession to map my body from the inside out now goes even deeper, right to the core of my brain.
So this is a diffusion tensor imaging scan, and basically what it allows us to do is look at the white matter in the brain.
Think of the white matter as the wires that connect the different parts of the brain and allow them to communicate. Diffusion tensor imaging is an MR-based technique that allows neurologists to get a good look at those wires or fibers and spot abnormalities that could hint at diseases like schizophrenia or multiple sclerosis. The colors indicate which directions the fibers are pointing. The amazing results could pass for my next album cover.
So what we did to generate this image, we just created a seed region. So we said, let's look at how the fibers come out from this part here. And this is the corpus callosum. And you can see it just radiates out between the right and left hemispheres.
And that's where the right and left hemispheres communicate with each other.
Yeah, exactly.
And let me just point out that this, what looks like an old gentleman here, a wooden version of an old gentleman, that's actually me. It's just rendered in a wood-like structure. Yeah, that's it. The more important thing, may I point, is my brain.